All right, here we go. Question 18 from our pre-calculus homework number 2. In MyLab Math, we have another word problem. Farmer Ed has 7,000 meters of fencing and he wants to enclose a rectangular plot that borders on a river. Now, since the plot borders the river, that means he's only going to need to fence 3 of the sides. It says if Farmer Ed does not fence the side along the river, what is the largest area that can be enclosed? So I thought that picture might be a little hard to see, so I tried to zoom in some here. The first thing we know is that this rectangular plot, is rectangular. And if I want to maximize the area, I'm going to need to know the formula for the area of a rectangle, which is length times width. And then if I know the length and the width in terms of x, I can write the area formula as an area function in terms of x. So this is our ultimate goal here, is to get the area function in terms of x. So if you look at the picture, the length along the bottom side, they have already labeled as 7,000 minus 2x. Let me explain where they got that. Remember, it said that the farmer had 7,000 meters of fencing to use. So if he uses some amount, which we don't know, for the 2 sides, then the remaining amount would be used for the length here. Okay, so now think about this. Whatever the length of these 2 sides, there's going to be 2 of them. So that's where the 2x comes from. And then to get the remaining length, you subtract those 2 lengths from your total amount of fencing. So just in case they don't give you this information, you can come up with this. So in our area function, the length is going to be 7,000 minus 2x. The width is going to be this distance here, which is just x. And then I do want to take one step to simplify in order to get rid of the parentheses. That's going to give me 7,000x minus 2x squared. That is my area function. Okay, next, remember they want the largest area, which is one way of saying they want to maximize the function. And since it's quadratic, it will produce a parabola. We know the maximum or the minimum value occurs at the vertex. So really what we're trying to find here is the vertex. So h is the x coordinate of the vertex. Since x is our variable and the x is used to determine the length of the side, then the h is not going to be the answer we're looking for because they actually want the area. No, the area is what you get when you plug in a particular value of x. So we're going to find that value of x that will maximize the area, which will occur at the x coordinate of the vertex. So that's going to be minus b over 2a, which b in this problem is the 7,000, and the a is negative 2. Using our handy-dandy calculator, knowing that a negative and a negative make a positive, that's going to be 7,000 divided by 4, which is going to give me a value of 1,750. That is the value of h, but remember that is also the x-coordinate of the vertex. So, x is 1,750. Now, to find the maximum area, we're going to find a of 1,750. So, going back up to our area function, we're going to take this function and we're going to replace each x with 1,750. And then we're going to pull up our handy-dandy calculator and calculate that area. and we get a very large area. So that area is 6,125,000. And since the units for x were meters, area is going to be square meters, which notice they do mention that right here in the problem. It is going to be square meters. Area is always square. Now, when I input this into the box, I don't think the commas are necessary. Just input the value and that should do it. If you have any questions or comments about anything covered in this problem, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.